we're cleaning up this area here. We're dropping the water table down for the sake of the demonstration so that we can see the water actually coming in underneath the wall and over top of the footing. And where the wall sits on the footing, it's called the cold joint. It's where of dry cement, the footing had wet cement, the walls sit on top of it, and then the wall dry. That seam is called a cold joint, and water passes through it, and that's how water gets into your basement. Now what I'm going to do is the hose test. When water comes through that seam, as we've been seeing it go and filling up this trench, it bypasses the gutter and it comes across here. But there's no drainage down within the depth of the footing. So the water fills up underneath the floor till it gets high enough that it will surround the gutter and then work its way around and back through those holes. But because of the lip on the holes, water just bypasses it. In other words, I'm going to put a hose here just to simulate what's going on. And if you see, the water's flowing underneath it. It's not going into it. It's not getting into the gutter at all. It's bypassing it and flowing right down underneath it. So now, if you're going to have water flowing across the footing, the idea is you have to set up drainage for it to go to, or else it just fills up around the floor, which is the worst idea. So if you were able to create your drainage in this trench between the top of the footing and the bottom of the footing, you're going to have about 12 to 14 inches to create the right amount of drainage. If you can do that, you've got a dry basement. This particular footing is extra wide. A normal footing is about 4 inches wider than the walls, about where my foot is right now. And you can see this one comes out a good 12 or 13 inches out. Creates a challenge for installing your waterproofing system. Not for us, we deal with this all the time. We're able to customize every inch of our waterproofing system. So now, because we have an extra wide footing, we have our flow channel, which is a drain board. And what we're able to do is we're going to take our drain board, put it in, figure out where it goes right up against the wall, and then we know right where we're at, that's right where it needs to be, and we're going to cut it so it fits this footing exactly. Okay, so we've taken our flow channel and now we've cut it and we can bend it so that it'll fit right into that angle right there, and it comes out right to the edge of the footing. We're going to be installing our drainage down here, so any water coming through will go across the footing, run down the face of the footing, and then we're going to have pipe and stone pitched to a heavy-duty commercial pump in a sump basket, and then that water would be pumped up out away from the house, and then we would re-cement the floor back to the full thickness of the floor, and then all of these pockets would be filled in by the concrete, permanently forming the channels that would allow any water coming in underneath the wall to flow straight through it and come down here. So we're going to take our hose and put it back here, and then release it and show you how the volume of water it can handle going through. Now our drainage is going to be all set up here where we're going to have pipe and stone pitched to our basket. So our flow channel is in. We're going to be setting up our pipe and our stone. And if you can focus on just how much drainage that we're installing and where we're installing it. Where you want to manage your water is within the depth of your footing, between the top of the footing here and the bottom of the footing. This area here is what we call the magic zone. If you set up your drainage so you're managing your basement water in this area here, you're creating a complete dry area underneath your floor. No water, if your drainage is all down here, no water is going to fill up any higher than that. Most important aspect of any subfloor water management system is the pitch and placement of the pipe. It's got to be pitched, but it must be done so in a way that it always stays within the depth of the footing, within that magic zone. So here's how it goes. We're going to set up our pitch, and then we're going to put an enormous amount of stone in. Setting up this entire area as drainage. So now we have pipe and stone in this entire trench, for any water coming underneath the wall, will pass through the flow channel and go have somewhere to go. Unlike the other systems that sit on top of the footing, there's nowhere for the water to go, so it has to just flood up around your floor, and your floor sits in water. We create drainage. We create a place for that water to go to, and it's down within the depth of that footing in that magic zone. Systems that sit on top of your footing, they don't have any pitch. There's no flow of water. It's just an overflow system into their basket. When that water recedes back out, a little bit of water gets trapped in there, and it grows fungus and bacteria and stuff called iron ochre. And it has to be flushed out annually, and there's a charge for that. Not the case. When you have this much drainage and it's pitched, the corrugated pipe, when water flows over the corrugations, it actually flushes itself out. So you have a maintenance-free system with an enormous amount of drainage that's able to manage the water low enough that your floor stays completely dry. If you've liked the video, please subscribe and hit the bell, and that'll notify you when our future videos are coming out. And thanks for watching.